Hello, and this is Math with Beth, and we're going to do area and definite integrals as part of calculus. So let's take a look. So here's the definition. Let f be any continuous function over the interval a to b, and capital F be any antiderivative of f. Then the definite integral of f from a to b is this. So basically, to do a definite integral, you just have an actual interval that you're looking at for a function. So you do the antiderivative and then you plug in b and subtract what you get when you plug in a. So let's do an example. So if I wanted to find the integral between -1 and 4 of this function, I would first do the antiderivative. So in this case, that just involves the power rule. So add 1 and divide by that same number, minus add 1 and divide by that same number. But now we're going to do this by plugging in 4 and then subtracting what we get when we plug in -1. So this is just a notation they use to show here's my antiderivative, and now I know I'm going to plug in 4 and plug in -1 and subtract them. So plugging in 4 would get us this, and plugging in -1 would get us this. So let's see what that would give us. Okay, so from -1 to 4, x squared. Okay, so this would be 64 over 3 minus 16 halves, -1/3 minus a half. All of that at the end would give us 14 and 1/6, which we're going to find out means that would be the area under that curve between -1 and 4. So now let's just do another one that involves the e. So if I wanted to do this definite integral, I would first do the derivative of e to the x, which is just e to the x. But now I need to plug in 2 and plug in 0 and subtract. So that becomes e to the second minus e to the 0, which is just 1. So my answer is just e squared, which is about this. Okay, so that leads us into the fundamental theorem of calculus. The fact that we can express the integral of a function either as a limit of a sum or in terms of an antiderivative leads us to this, the fundamental theorem of calculus, which basically just explains that since the limit involved of adding all of these up would be the same as what we just did. So to find, again, the area under a curve from A to B, you do what we were just doing. So this is the fundamental theorem of calculus. So if we wanted to do something like this, find the area under the graph of 1 over x squared from 1 to 10, we could set that up with an integral. And now we solve that by doing the antiderivative. So since this is really x to the -2nd, I can add 1, which gives me -1, and divide by that. But now we need to plug in 10 and 1. So basically that's like -1 over 10 minus -1 over 1. So -1/10 plus 1, which equals 9/10. So 0.9 or 9/10 would be our answer. So that's basically it for finding definite integrals or using the fundamental theorem of calculus. Let me know if you want to see any more examples or if you have any questions on that, just send me a message or give a comment. Thank you.